Good morning, afternoon, and evening, ladies and gentlemen of the world, and welcome to the Elipsis & Co. Tutoring channel, where today we will be continuing with the numbers topic in the IGCSE Maths syllabus. In this video, we will be talking about the first concepts of ordering numbers. So, without further ado, let's begin. For starters, let's consider the first 5 numbers after 0. We can obviously tell that the number 2 has a greater value than 1, so the number 2 is larger than 1 when ordered. In a simple sense, ordering is arranging numbers from the smallest number to the largest number. When we start from smallest to largest, we call this ascending order, while when we start with the largest number and go down, we call this descending order. Ordering numbers is pretty simple when we only consider natural number like 5, 10, and 20. However, they get a little tricky when considering negative numbers. The reason being is that negative numbers often work backwards compared to natural numbers. For example, let's say we wanted to order the numbers 5, 16, -9, -1, and 11 in ascending order. Now, as I said before, ordering numbers is arranging them from lowest to highest. So therefore, we have to start with the lowest number. Most people might think the lowest number is -1, because 1 has the lowest value compared to the other numbers. However, the lowest number is actually -9, because when considering negative numbers, the higher the number, the lower the value. So, once we can understand that fact, we can know that the order of these numbers in ascending order is simply -9, -1, 5, 11, and 16. Now, in a practical sense, ordering numbers is actually very important when calculating values. For example, if we had these 5 masses of bricks and we wanted to order them in ascending order, how would this look? Well, firstly, we would have to understand that 1 kilogram is equivalent to 1,000 grams. So it would make sense to convert the values first before trying to order them. I am going to convert them all into gram, which will make them like this. And now it's simpler. Therefore, the ordering would be 175 grams, 800 grams, 1,200 grams, 1,500 grams, and 2,000 grams. Don't forget, in the end, you must convert them back to their natural state. Just for reference, here is a quick list of most of the practical quantities you might be given to order in your exams. Now, when we talk about ordering larger quantities, it is very important for you to consider the place values of certain numbers. For example, 1,500,000 is very different from 1,050,000. When ordering these numbers, the first one is bigger. What if we get asked to order these numbers in descending order? Well, firstly, what we can tell from these numbers is that the first 2 place values from the left are all the same, so we do not have to consider them. The third places, however, are different, so those are the ones we consider. The answer that you would be looking for looks like this. Similarly, when ordering decimals, we, once again, need to consider our place values. For example, let's say we wanted to order these numbers in ascending order. As you can see, there are a combination of 0s and 4s, however, the place values are different. Furthermore, with decimals, we must remember that the value of a number gets smaller the further it is from the point, and the higher the place value is, the lower the number is. So the first number would be 404 10,000ths, then 404 hundredths, then 404 hundred-thousandths, then 44 thousandths, and 44 10,000ths. Therefore, we would find the final ordering would be this. Note that if you wanted to make life simpler, you could just multiply every number by the same value to remove the decimals. In this case, you could multiply them by 100,000 to make them look like this. Moreover, we can even order fractions of different sizes. It's pretty easy to order fractions with similar denominators. However, when faced with something like this, it can seem pretty difficult. To solve this, we need to understand how to distinguish which fraction is bigger compared to the other. For example, let's take 1 over 5 and 2/3. As we say in previous videos, these fractions are off different sliced objects, so the first thing we need to do is make these fractions of a common denominator. Therefore, we need to find the lowest common multiple of the two denominators, which is 15. Then, we just convert the two fractions to fit the new denominator. Now the fractions will be 3 over 15 and 10 over 15, showing that 10 over 15 is larger than 3 over 15, and therefore we would order them like this in ascending order. This concept is the same even for percentages. Let's say we wanted to order these 5 numbers in descending order. Since these numbers are in different forms, the first thing we need to do is convert them to a form that is easy to understand. For me, I'm going to convert into decimal form. 1/4 is just 0.25, 3% is 3 over 100, which is 0.03. 0.41 remains the same. 11 over 40 is 11 divided by 40, which is 0.275. And finally, 0.35 remains the same. Therefore, in descending order they would look like this, but don't forget to convert them back to their natural form. Our final concept of the day is understanding inequalities. From the name, we can already tell that inequalities show two values which are not equal or unequal. These inequalities come in the form of notations, and there are 5 inequalities. The first 2 are called the less than or greater than sign. These simply show that one value is less than or greater than another value. For example, we can write 5 is less than 7. What we notice is that the sign points towards whichever value is the largest. So an example of greater than would look like this. A way you can remember this is if you picture the signs as crocodiles, and the crocodile wants to eat the larger number. The next 2 signs are the less than or equal to and the greater than or equal to signs. These signs are similar to the previous, except if 2 values could be the same, we use this notation. For example, if we said at least 5 cars were blue, we are saying that there could be exactly 5 or greater than 5 cars which are blue, so we would write this as 5 is greater than or equal to blue. However, if we had said more than 5 cars were blue, we would write that 5 is greater than blue. Finally, the last sign is the not equal to sign. This sign literally means that 2 values are not equal. For example, 2 is not equal to 3,